Welcome to the first video in this series, Survival Analysis in your browser. In this video, we will be discussing generating survival times. So why might you want to generate some synthetic survival times? Well, if you can view it as a positive control. If your analyses don't work on your synthetic data, they're probably not going to work on your actual data. And you could also view it as a power analysis if you haven't yet collected your data. It can help you determine how many patients to enroll in a study. So let's just quickly look at generating some times, and then we'll go into the details of exactly what happened. So we need to go to Survival, Generate Data. We need to have a relationship between our feature and our target. Here, there's no relationship. So for each input in actual data, your feature would be something like age, tumor size, number of cigarettes smoked per week, something like that. And then your target is a risk. And here there's no relationship. So when we make the data and we then go to the analysis and we split on the input at the 50th percentile, there's not going to be any difference in survival. And if we try to find the optimal cutoff, these values aren't going to be very high. But if we go back to the data, back to our features, and we have a strong linear relationship between, for example, smoking and risk, and then we now make this survival data and submit that, we will now see a very strong difference. And if we find our cutoff, we'll have very large log rank values. Okay, so what was all that we just did? Generating survival data is a multi-step process. You have to go from your input features, which in actual data would be something like age, tumor size, and then you have to make risks. And then those risks make the time event data. And the event is whether or not you observed a patient dying, for example, or you observed the disease coming back, or it doesn't even have to be something biological. It could be an engine failing. And you have a censoring function which determines whether or not an event occurred. So in actual data, you have the features, you have the times and events, and then you're trying to figure out what the risks for each sample are. So how do we go about making this time to event data? So you can use this exponential distribution, which is the simplest distribution because the rate of failure does not depend on time. So you have the same rate at all time points. And it looks a little complicated, but it's not too bad. U is just a random number between 0 and 1. And because the log of a number between 0 and 1 is negative, we have a negative here, so our times will always be positive. Lambda is the baseline hazard, and then beta prime x is just the risk. So we can really simplify this function. It's really just proportional to a random number over your risk. So the larger your risk, the smaller your time. And it's important to keep in mind that you have this random nature of survival times. Two samples with different risks, just based on chance, the same risk based on chance can have different times. And someone with a higher risk can actually survive longer than someone with a lower risk, just again, based on chance. But the larger the difference in risk, then the less likely that is to happen. Now, what's this baseline hazard that we talked about? I just define that as 1 over the mean survival time. I allow users to provide the mean survival time. It doesn't change the shape of the curve. All it does is change the scale. So it doesn't really matter what you put for this unless you're trying to match data set exactly. For example, you're trying to match the exact time and days of a actual data set, but it doesn't really matter what you put for the mean survival time. So that was the event time. What about the censoring time? For this, I used a more complicated distribution. I used a Weibull distribution. So that has the same lambda as a scaling parameter, but now we have a shape parameter. So I did this to give users more control over the censoring time. And the lambda is also a little bit more complicated. You need the censoring time to be similar in scale to the event times. Otherwise, you're going to have every patient censored or no one censored. So what I did is I again defined it as 1 divided by the mean survival time, but then I give users the scale parameter to slightly adjust it if they need to adjust it. But oftentimes, you probably won't need to adjust it too much because they'll start out on a similar scale. And then you'll have the additional shape parameter if you need further adjustments. And you can really simplify this formula as just a random number times the scale that you choose, and then if you decide to add the shape parameter. So how does the censoring time work? So if the censoring time is longer than the event time, then we observed an event. If the censoring time is less than the event time, we did not observe an event, and then we'll have a 0 there. So why do we have censoring? Because in a survival study, let's say the study lasts for 5 years, at the end of those 5 years, if you still have patients who haven't died or their disease hasn't recurred, then we never observed the event under consideration. Or we can lose patients. For example, they might move to a different city and you lose contact with them. Okay, now with all that in mind, let's go back to these times. Okay, let's go back to the data. And let's go to the features. So let me demonstrate why we might need to adjust the survival, the censoring time. So these risk values of 4 are quite high, and they can get higher if I adjust the scale here. Typically, you probably want them between -1 and 1, but these are going to be pretty high. And the risk affects the event time, but does not affect the censoring time. So if you have very large risk values, you're going to have to adjust your censoring. So let's just see what happens. Let's make some survival data. We can look at our event counts right here. As I said, those were very large risks. Now I can go to my risk options and I can lower the risks. And I can make the survival data again. And now we have much fewer events. But let's say I wanted to have large risks. And I also want to have a more even distribution of censoring. This is where our sensor scale and sensor shape come in. As I mentioned, the mean survival time really has no impact on this curve. So if you adjust this to your heart's content, it's really not going to do anything. All it does is change the scale on this x-axis. So adjusting this value really is not what you want to be adjusting. You want to be adjusting these two values to affect the frequency of your events. So we discussed the sensor scale, and we said, we have a little helpful tip here. We said that if you increase this, your censoring times will increase. And so if your censoring time increases, then you observe more events. So let's see. This is taking a little bit of time, but I think we can see that as this goes up, we have more events. And then if we want to adjust further, we could also use the sensor shape. But what we actually wanted to do was to make this distribution more similar. So we need to decrease this value. Oh, that was too much. There we go. That's about even. So we can have large risks and then still have a pretty even distribution of censoring if that's what we desire to do. So let's go back to our features and just go over this one more time. So we can choose our samples here, our features here, and our targets here. One thing to keep in mind, though, is that our risks need to be a single dimension. So we can't have two targets unless we click this switch button here. That's a little bit too advanced to go into right now, but if we try to make this, we're going to get a little error message. So we have to have one target, but we can have more features if we want. And these features are completely independent of each other. So we can have more features, but if we have extra features, then when we submit the data after making survival times, we're not going to have the analysis panel anymore, because the analysis panel relies on splitting the data on a single feature. You can't really easily split your data when you have 4 features. So if you want the analysis panel, you have to restrict yourself to 1 feature. Okay, so in the next video, we'll be going into analyzing data that we've generated. Thank you.